Kumar. So, Subhankar Sahu, Sumit, Sriman Patro, Jyoti Prakash Samal, Arpita Dio, Asit Kumar. Only three, 6 minutes. Subhankar Sahu. Good morning, Subhankar. Right. We'll see here some of the deuterated water today itself. We'll discuss. Deuterated water. You know water, that is H2O, you know. Okay. Okay. That is right. Deuterated water. You know H2O. Instead of hydrogen, there will be D. D for deuterium. Okay. So deuterium here is. Yes. Good morning, Bagiraj, Shubhadeep, Asit Kumar, Shubhankar Sahu. Okay. All of you, Arpita and as Suman Petro. Right. Asit Kumar. Right. See, this is deuterated water. So let's we see its preparation here. This deuterated water is used in what? Nuclear reactors. Deuterated water is useful for the in the nuclear reactors as moderator, right? And this is also used in some reaction mechanism. Okay, as a tracer. Okay, as a tracer. So first we will see the preparation of deuterium oxide, that is heavy water, deuterated water or heavy water. इसको heavy water भी बोल सकते हैं. First, this is preparation. How to prepare this one, right? So we'll take here is this is a nickel content. This is nickel rod. Okay, this is nickel cathode. This is negative. This is steel vessel. This is positive anode. This steel vessel itself acts as deuterium oxide, D2O. This is ordinary water. This is ordinary water. Okay. So now this is a vessel, right? Itself acts as anode. This is what minus cathode. This is nickel. Nickel electrode. This is perforated nickel. This is perforated nickel cathode. So like this. In this there is outlet. Gases goes out. this is the cell for the preparation of deuterium oxide. Okay, this is the cell for the preparation of deuterium oxide, right? So like this, there are many large number of cells are taken in for the preparation of this deuterium oxide. See, इसको अभी क्या ले रहे हैं यहाँ पर ordinary water. So how the deuterium oxide can be prepared here is means prolonged electrolysis of ordinary water. अभी आप इस सेल में, okay, a steel vessel is taken, a nickel rod, right? This is the nickel rod. Okay, this is nickel rod. This is nickel rod. The perforated nickel rod here is perforated means a porous. Okay, that is nickel rod. So this nickel rod here is इसमें वाटर लेते हैं, ऑर्डिनरी वाटर लेते हैं, इसमें कुछ गैसेस फॉर्मेशन होने से बाहर जाने के लिए. This steel vessel is acting like an anode, positive electrode. This perforated nickel cathode is acting like a negative electrode. This is negative electrode. This is positive electrode. Means steel vessel itself acts as a anode, right? Steel vessel itself acts as anode. So now we are taking what? Ordinary water. You are taking what? Ordinary water. So this ordinary water, okay, means the presence of D2O here is D2O is present here. Okay, how much D2O here is 1 by, okay, so that is 1 mole of, I mean 1 part of D2O is present in 6,000 part. 1 part of D2O is present in 6,000 parts of ordinary water. See, this is of 6,000 part ordinary water लेने से उसमें 1 part रहेगा. 1 part means D2O presence is in the ordinary water is D2O. Okay, in ordinary water is 1 by 6,000 parts. D2O in ordinary water is 1 by 6,000 parts. Right or not? Means 6,000 part of ordinary water रहने से उसमें 1 part D2O रहता है. That is D2O in ordinary water is equal to 1 by 6,000 parts. Okay, so such a less amount, 1 part of D2O in 6,000 part of ordinary water. See how much little that is of D2O. So that is the little fraction here is that is. So now here this prolonged, you mean you have to prepare D2O. So by taking ordinary water, so this ordinary water contains what? 1 part of D2O. This ordinary water contains what? 1 part of D2O out of 6,000 parts. That is D2O presence is 1 by 6,000 part. Okay, means इतना कम है ordinary water में, लेकिन उससे prepare करना है अब D2O, right? That is nothing but you are doing which electrolysis? Not normal electrolysis. That is prolonged electrolysis. That is prolonged electrolysis, right? That is prolonged electrolysis of ordinary water करने से आपको deuterium water, deuterated water और D2O heavy water आ जाएगा, right? You see, this is the vessel here is apparatus. I mean, you have to take here in this for prolonged electrolysis. You have to take large number of cells. You must use. Okay, large number of cells should be used. Should be used for the preparation of D2O. Deuterium oxide के लिए एक सेल नहीं, many cells you have to take, right? Large number You have to take many number of cells. Should be used. Okay, should be taken here. Should be taken for the preparation of D2O. आप कितना लेना है? Many large number of cells should be taken for the preparation of D2O. With a single cell, you cannot prepare D2O. You must take such type of cells. Large number of cells you have to take. Okay, that is so that large number of cells and also prolonged electrolysis only. That those conditions only are possible for the preparation of D2O. Right? Next one, the apparatus used is, there is apparatus क्या है? Steel vessel. Okay, it's a steel vessel acts as, that is anode, which is positive. Okay, and perforated nickel electrode, okay, acts as cathode, which is negative electrode, So the electrolyte used is electrolyte is n by 20, मतलब 1 by, sorry, not n by 20, n by 2, n by 2 NaOH aqueous solution. N by 2 NaOH aqueous solution, you have to use the electrolyte here. Okay. इस ऑर्डिनरी वाटर में आप क्या लेना है? Some NaOH should be taken here. That concentration of that electrolyte should be n by 2 NaOH and the total solution is aqueous solution. इसमें आप n by 20 ऑर्डिनरी वाटर है, लेकिन इसमें n by 20 sorry n by 2 NaOH concentration रहेगा. इस ऑर्डिनरी वाटर concentration कितना है? n by 2 NaOH, उसमें NaOH डालना है. That concentration of that must be n by 2 NaOH. Okay, so this is okay. You have to do this. Means here the number of stages in this is 7 stages. Okay, 7 stages. See how the D2O is prepared. You have to prepare through the prolonged electrolysis of ordinary water. Okay, ordinary water is having 1 part of D2O. Okay, out of 6,000 parts, that is large number of cells should be taken for the preparation of D2O. Apparatus steel vessel acts as anode and perforated nickel electrode acts as cathode, and electrolyte is n by 2 NaOH aqueous solution. And so how many stages here? Not one stage, here is 7 stages. Okay, steps, 7 stages. After 7 stages only you are getting what? Okay, after 7 stages only, okay, we get 99% of D2O after 7 stages. So how many stages will be there in this prolonged electrolysis? Means 7 stages of electrolysis. 7 stages of electrolysis. This is after 7 stages. Okay, only we get after 7 stages we get 99% of D2O. Okay, this 99% of D2O. Okay, on fractional distillation. Fractional distillation. Okay, 99% D2O on fractional distillation. Okay, gives pure D2O. This is pure D2O आपको आ जाएगा. So pure D2O you are now preparing. Okay, pure D2O you can prepare now. That is deuterated water or heavy water you can prepare. So after 7 stages, here is 99% of D2O you can obtain. After that, 99% of D2O, okay, you have to, so I mean, purify under fractional distillation. So upon that purification of fractional distillation, you will get what? 100%, that is pure D2O आपको आ जाएगा. That is the way of preparation of D2O. Okay, समझ में आना ये? So that is the D2O here in this you are going to see this in this. Okay, so that is means this finally for 30 ml. Okay, so here is for 30 ml, right? For 30 ml of for 30 ml of ordinary water, for 30 ml of ordinary water, 1 ml of D2O, okay, will be obtained in this prolonged electrolysis. So क्या है last point? For 30 ml of ordinary water आप लेने से 1 ml D2O you are going to get. How much ml? 1 ml D2O. आप 30 ml ordinary water use करने से out of 30 ml you are going to get here is D2O of 1 ml you are getting. Okay, so that's the preparation of D2O, right? Right, now we see the properties of D2O. Preparation ये है अभी properties, right? Physical properties of D2O. Okay, this is colorless, odorless. Okay, like water only, colorless, odorless, and mobile liquid. Right? So freezing point will be 3.82 degrees. Okay. For water, for H2O, this is 0 degrees Celsius. Right or not? For H2O, 0 degrees Celsius. Boiling point is 101.42 degrees Celsius. For H2O, this is 100 degrees Celsius. Right or not? Molecular weight is 20. For H2O, here is 18. Right or not? Molecular weight here is 20. Molecular weight is 20. Here is H2O molecular weight is 18. Specific heat is specific heat here at 20 degrees Celsius. This is 1 kilocalorie per mole. Here is for H2O 1.01 kilocalorie. Here is 1.1 kilocalorie. For H2 1 kilocalorie. Bond energy. Okay. D2O is greater than H2. DOD bond is strong. DOD bond is strong. Then H2H bond. This is weak. Okay, comparison में बॉन्ड एनर्जी किसको ज्यादा है, इसको ज्यादा है, स्ट्रॉन्ग बॉन्ड। therefore reactivity देखने से D2O का प्लस reactivity H2O की ज्यादा रिएक्ट। acidic nature देखने से D2O is less acidic than और Ka values। See, colorless, odorless, mobile liquid, freezing point is 3.82. Water के लिए कितना है? Freezing point 0 degree Celsius. Boiling point 101.2, 101.42 degrees Celsius. And for water here is 100. Molecular weight is 20, means for water 18. Specific heat at 20 degrees Celsius 1.01 here is kilocalorie per mole, means for water 1 kilocalorie per mole. Here is bond energies for D2O is greater than H2O. D2O मतलब bond energies को ज़्यादा है, मतलब OD bond is stronger. OD bond is stronger. Okay, so bond energies को ज़्यादा है than this OH. So therefore it is a weak. Therefore it can lose H plus. Right? Therefore, this is more acidic. It can lose H plus or not. Therefore, acidic. H2O is more acidic. This is weak or not? Weak bond means it can lose H plus. Therefore, this is more reactive and more acidic. H plus को छोड़ने से क्या है? More reactive है. More reactive है, इसको reactivity ज़्यादा है और acidic nature भी ज़्यादा है कि नहीं? Acidic nature ज़्यादा है और रिएक्टिविटी ज्यादा है। एसिडिक नेचर और Ka वैल्यू बोलते हैं, Ka वैल्यू इसको ज्यादा है। सो दैट इज व्हाट these are the physical properties. These are physical properties of D2O. Okay, physical properties. Okay, right. So now we will see the chemical properties. Chemical properties of D2O. Chemical properties of D2O देखने से, right? See chemical properties here. D2O has similar chemical properties. D2O has similar chemical properties with H2O. Similar chemical properties like H2O. But the rate of the reactions are less for D2O. The rate of reactions are less for D2O. Means D2O reactions. Speed of the reactions are less for D2O than H2O. Okay? Then H2O. Slow reactions with this D2O. Okay? Now we see here the chemical properties. First one reacts with D2O reacts with metals. Okay, sodium metal plus D2O. Sodium metal plus D2O. You are getting NaOD plus D2. You see, sodium metal is also reacting with water to form NaOH. Sodium hydroxide or not? Plus H2 will be released. See H, यहाँ पर H2 है, H2 means 2NaOH, therefore 2Na और लेना है, 2Na लेने से 2Na ऑक्सीजन भी दो रहना है, so hydrogen ड्यूरेट हो जाएगा. So this is the balanced reaction. See, water is reacting with sodium and liberating what hydrogen gas along with sodium hydroxide formation. The same reaction यहाँ हाइड्रोजन के जगह D लेना, सिर्फ हाइड्रोजन की जगह D लेने से ये हो जाएगा D2O. If you are taking Na, D2O means this is NaOD formation, right? See the balancing how you have to do. NaOD, Na reacts with D2O, NaOD. Therefore, how many D are there? 2D. Therefore, you have to take 2 here. You get 2 sodium here, 2 sodium, 2 oxygen here, 2 oxygen here. इसलिए 2 लेना है, 2 oxygen. Sodium बैलेंस हो गया, oxygen बैलेंस है, और बाकी 2 है. That is D. 4D बैलेंस हो गया. Same thing. यहाँ पर ड्यूटेरियम आ रहा है, फॉर्मेशन हो रहा है. यहाँ पर हाइड्रोजन फॉर्मेशन हो रहा है. That is NaOH there. This is NaOD. Right? इसका सोडियम हाइड्रोक्साइड बोल सकते हैं. सोडियम हाइड्रोक्साइड. See, D2O has similar chemical properties. Similar chemical property. Property similar है कि नहीं? देखो. But the rate of reaction is less for D2O. This reaction is slow. This reaction is fast. This reaction is slow. This reaction is fast. Why? Because DOD bond is strong or not? DO. This is why this is slow. Why this is fast? आपका अभी दिया ना. D2O has similar properties like water. Like water, it is also having similar property. But the rate of reaction, if you see, rate of reaction किसको ज़्यादा है? इसको ज़्यादा है. Water reactions को ज़्यादा है. क्योंकि H2OH, OH bond is weak or not when you compare with this. This is OD bond, DOD bond. This is strong. So this एक क्लियर होने के लिए थोड़ा समय लगेगा, टाइम लगेगा. OD bond क्लियर होने के लिए टाइम लगेगा, इसलिए slow reaction. This is slow, this is fast. इसलिए बोला ना, the rate of the reactions, okay, are less for D2O than H2O, right? Because OD bond is strong. Bond dissociation energy किसको ज़्यादा है? D2O में OD bond को ज़्यादा है और OH water में OH को कम है, right or not? So that now see reacts with metals. D2O is reacting with metals. Water is also reacting with metals. Potassium, D2O, KOD, right? 2 deuterium, KO and deuterium 2 है, इसलिए 2 लेयर, 2 ऑक्सीजन हो जाएगा, 2 लेयर, 2 पोटेशियम हो जाएगा, 2 पोटेशियम. So 4D है यहाँ पर, so इधर D, right? So same thing here also 2K plus H2O, 2H2O, that is 2KOH plus H2. Right, same reaction, but the speed is different. Which is slow reaction? This is slow reaction. This is fast reaction. If these are first year elements, these are first year metals. And if you see, magnesium is the second year element. D2O, MgO, okay. D2O से react होने से MgOD taken twice. D2O you लेने से आपको MgOD taken by this is see this is also Mg plus D2O यहाँ पर H2O right you are getting MgOH taken twice plus H2 means magnesium hydroxide this is potassium hydroxide, sodium hydroxide, potassium hydroxide, magnesium hydroxide. See, this is sodium hydroxide. This is sodium hydroxide. Sodium hydroxide. This is sodium deuteroxide. Sodium deuteroxide. This is potassium deuteroxide. This is magnesium deuteroxide. Right up. Magnesium deuteroxide. This is magnesium hydroxide. Hydrogen है तो hydroxide. Deuterium है तो deuteroxide. If you see calcium, if you take 2D2O, same thing CaOD taken twice plus D2. This is calcium deuteroxide. Calcium deuteroxide. right or not? अब इधर क्या लेना है Ca plus H2O CaOH taken twice plus H2 this is 2H2 right यहाँ पर कैल्शियम हाइड्रोक्साइड कैल्शियम हाइड्रोक्साइड समझ में आया ना reaction with metals D2O is reacting with metals like water only exactly समझ में आया क्या ये रिएक्शन सबको everybody understood these reactions okay now we'll see yes very good okay reaction with metals just like water only but the rate of reaction is different because D2O में strong bond energy है bond energy OD bond पर strong है इसलिए वो दिक्कत होता है break होने के लिए इसलिए ये slow reaction है OH bond is comparatively इससे compare करने से OH bond is weak bond इसलिए cleavage हो जाएगा fast reaction है वो बस next one reaction with second one reaction with metal oxides reaction with metal oxides this is sodium is a metal right इसका metal oxide Na2O है इससे ये रिएक्ट होता है NaOD बन जाएगा कितना मतलब 2 NaOD बन जाएगा so like this right Na2O plus water Na2O किससे रिएक्ट हो रहा है D2O like water NaOH कितना बन जाएगा 2 sodium hydroxide बन जाएगा Na2O is reacting with D2O to get what 2 NaOD Na2O is reacting with H2O to get what 2 NaOH यहाँ पर आप Mg लेने से D2O that is MgOD taken twice MgOD taken twice magnesium deuter this is magnesium hydroxide आने से magnesium deuteroxide बोल सकते हैं so that is MgO plus H2O MgOH taken twice. This is magnesium hydroxide. This is magnesium deuteroxide. Hydrogen रहेगा तो hydroxide, deuterium रहेगा तो deuteroxide. Sodium hydrogen है ना, sodium hydroxide. This is sodium deuteroxide. Deuterium है तो deuteroxide. Sodium deuteroxide. Sodium deuteroxide. Magnesium deuteroxide. This is magnesium hydroxide, sodium hydroxide. ऐसा. If you take calcium oxide here, these all are metal oxides, right? metal oxides. So calcium metal oxide, यहाँ पर CaO plus H2O, CaOH taken twice, calcium hydroxide. Okay, so these are reaction with metal oxides. Means deuterium is reacting with metal oxides like water. So always these are slow, these are fast. All these reactions are fast. These are slow reactions. These are fast reactions comparatively. Okay. Right? Okay. Next one. This is called reaction with non-metal oxides. Non-metal oxides. Right. Reaction with non-metal oxides. See, what is this non-metal oxide means? Sulfur is a non-metal, right? इसका oxide है SO3 and reacting with D2O and forming what? D2SO4. You see here, to understand this thing, sulfur trioxide, right? Sulfur trioxide is reacting with H2O and forming what? H2SO4. सल्फ्यूरिक एसिड, इसका नाम क्या है? सल्फ्यूरिक एसिड. इसका नाम क्या है? ड्यूटरेटेड. यहाँ पर ड्यूटरेटेड वाटर बोल रहे कि नहीं? ड्यूटरेटेड वाटर है ना? देखो दिस इज ड्यूटरेटेड सल्फ्यूरिक एसिड. ड्यूटरेटेड सल्फ्यूरिक एसिड, राइट? If you take N2O5 plus D2O, see this is N2O5 plus H2O, right? So that is HNO3. 2HNO3 आ जाएगा. इसको क्या बोलना है? नाइट्रिक एसिड. नाइट्रिक एसिड. इसको अभी क्या आता है? DNO3. 2DNO3, that is deuterated sulfuric acid, means this is deuterated nitric acid. Deuterated nitric acid, right or not? This is sulfuric acid H2SO4. This is D2SO4, deuterated sulfuric acid. This is HNO3 nitric acid. This is deuterated nitric acid, DNO3, deuterated nitric acid. Okay. If you take P2O5, this is nitrogen pentoxide. This is nitrogen pentoxide. This is phosphorus pentoxide. Phosphorus pentoxide. This is nitrogen pentoxide. तो phosphorus pentoxide को D2O ऐड करने से क्या आ जाएगा? देखो P2O5 phosphorus pentoxide को H2O ऐड करने से H3PO4 आ जाएगा. This is phosphoric acid. इसका नाम क्या है? Phosphoric acid. That is H3 means 3H2O, 2 phosphorus. H3PO4. See, phosphorus pentoxide को water add करने से 3 moles you are getting 2H3PO4, that is phosphoric acid. HORIC, phosphoric acid, that is phosphoric acid. यहाँ पर D3PO4, H के जगह D यहाँ पर लिखना है 2D3, that is D3PO4 इसका नाम क्या है? ड्यूटरेटेड फास्फोरिक एसिड. दिस इज फास्फोरिक एसिड, दिस इज ड्यूटरेटेड फास्फोरिक एसिड. Okay, like that. So that is deuterated phosphoric acid. आपको वाटर से सल्फर ट्राइऑक्साइड, वाटर सल्फ्यूरिक एसिड, नाइट्रोजन पेंटॉक्साइड, वाटर नाइट्रिक एसिड, phosphorus pentoxide, water phosphoric acid, sulfuric acid, nitric acid, phosphoric acid. Sulfuric acid there with water means SO3 with D2O, deuterated sulfuric acid, N2O5 with D2O, deuterated nitric acid. This is deuterated phosphoric acid. Sulfuric acid, deuterated sulfuric acid, nitric acid, deuterated nitric acid, phosphoric acid, deuterated phosphoric acid. समझ में आया क्या? नॉन मेटल ऑक्साइड से अभी दिस आर द टाइप्स ऑफ ऑक्साइड्स आपको आ जाएगा. ड्यूटरेटेड सल्फ्यूरिक एसिड, नाइट्रिक एसिड, फास्फोरिक एसिड, लाइक दिस, राइट? ओके, सो दीस आर द एसिड्स, नॉन मेटल ऑक्साइड्स. दीस आर रिएक्शन. नेक्स्ट वन. Okay, now this is fourth one, reaction with nitrites. Okay, reaction with nitrites. Aluminium nitride reacting with D2O. Okay, giving what? AlOD taken thrice plus MD. This is aluminum nitride reacting with water and forming AlOH taken thrice. This is aluminum trioxide, that is, along with ammonia. That is ammonia. See, aluminum nitride इसको बोलते हैं aluminum nitride. Okay, aluminum nitride. This is Al. Al first it is reacting with water, right? So आपको कितना AlOH taken twice आ जाएगा? Aluminum hydroxide. This is aluminum hydroxide. Means तीन ऑप्शन इधर है, 3H2O, right? aluminum एक है, नाइट्रोजन एक है, ऑक्सीजन भी है, 6 हाइड्रोजन बैलेंस. That is ammonia you are getting. See, aluminum nitride with water you are getting aluminum hydroxide and ammonia. Same thing there is 3H2O means you have to get 3D2O. This is aluminum deuteroxide. This is deuteroxide. Aluminum deuteroxide plus deuterated ammonia. Deuterated ammonia. ND3 means deuterated ammonia. This is aluminum deuteroxide. Okay. Now if you see magnesium nitride Mg3N2 3, that is sorry, Mg3 D2O, right? What you are getting here? Mg3 N2 nitride. This is H2O. MgOH taken twice. MgOH taken twice. कितना मैग्नीशियम? 3 मैग्नीशियम है और नाइट्रोजन कितना है? NH3 है 2 नाइट्रोजन. See, everything is getting balanced or not? 6 hydrogens, 6 hydrogens. Therefore 6H2, right? So that is magnesium nitride. इसका नाम क्या है? Magnesium nitride. इसका नाम magnesium nitride है. अभी magnesium nitride is reacted with water, magnesium hydroxide. This is ammonia. Magnesium hydroxide means you are also getting here is with 6D2O, 3 magnesium OD taken twice plus ND3, 2 ND3. This is, you know that, you know this magnesium deuteroxide, you know this is ammoniated, deuterated ammonia. ND3 means deuterated ammonia, deuterated ammonia. Balanced or not? Balanced or not? So like reaction with nitrides, aluminum nitride, magnesium nitride पानी से react हो रहे हैं. Aluminum nitride is giving what? Aluminum deuteroxide plus ND3 deuterated ammonia, right? That is like water only. Aluminum nitride is with water, aluminum hydroxide, ammonia. यहाँ पर magnesium nitride water से magnesium hydroxide and ammonia दे रहे हैं. यहाँ पर magnesium nitride is react with deuterated water and giving what? Magnesium deuterated oxide and deuterated ammonia. So same thing, same reactions. लेकिन हाइड्रोजन की जगह ड्यूटेरियम रखना, हाइड्रोजन की जगह ड्यूटेरियम यहाँ पर रखना. ओके, दैट इज नाइट्रेट्स. नाउ अभी तक कितना हुआ? रिएक्शन विद मेटल्स, मेटल ऑक्साइड्स, नॉन मेटल ऑक्साइड्स एंड नाइट्रेट्स, राइट? नाउ विल सी रिएक्शन विद हियर इज फॉस्फाइड्स. ओके, so now fifth reaction, right? Oh, fifth reaction with phosphides. This is fifth one. Phosphides are arsenides. Phosphides are arsenides, right? So which phosphides? Calcium phosphides plus D2O, what you are going to get. Okay, Ca is giving what? OD taken twice, calcium hydroxide plus phosphorus is giving what? PD3, means phosphorus, phosphine. This is 3 calcium है, phosphorus 2 है. This is deuterated phosphine, group. Deuterated phosphine. This is deuterated calcium hydroxide, deuterated calcium oxide, right? This is Ca3P2 plus H2O. You are getting what? Calcium hydroxide, 3 calcium hydroxide, 3 plus phosphorus PH3 2 है. इसको phosphine बोलते हैं. This is calcium hydroxide, means this is deuterated calcium hydroxide. अब this is deuterated phosphine आ जाएगा. So you have to balance this oxidants, means 6 oxidants. 6 oxidants. Here also 6. See, phosphine is reacting with water. This is calcium phosphide. Sorry, calcium phosphide. This is what? Calcium phosphide is reacting with, okay? Calcium phosphide is reacting with water, forming what? Calcium hydroxide and phosphine. This is PH3. PH3 को क्या बोलना है? Phosphine. तो सेम रिएक्शन हाइड्रोजन की जगह what D रखना है. Calcium phosphide is reacting with oxide, and you are getting what? Deuterated calcium oxide, calcium deuterate oxide or deuterated calcium oxide. This is what? Deuterated phosphine. pH means phosphine, deuterated phosphine. This is right. So if you see arsenides, arsenide means what? Na3As. This is sodium arsenide, right? This is reacting with D2O and NaOT. कितना सोडियम 3 सोडियम है प्लस आर्सेनिक 1 है AsD3 AsD3. So 3 ऑप्शन है इसलिए 3 ऑप्शन है इसलिए 3. Therefore everything is getting balanced figures. Sodium arsenide is combining with deuterated water, right? And you are getting AsD3 is deuterated आर्साइन. इसको आर्साइन बोल सकते हैं. AsH3 को आर्साइन बोलना है. मींस Na3 arsenic plus H2O giving what? NaOH 3 है plus 3 NaOH plus AsH3. This is arsine. Arsine. Oxide, okay? This is sodium hydroxide. So total oxygen 3 है इसलिए 3 बैलेंस नंबर. So arsine है तो this is deuterated arsine. arsine है तो क्या है? ये क्या है? deuterated arsine है. ArSine. See, this is reacting with phosphides and arsenides. Phosphide, calcium phosphide. Deuterated water आपको deuterated phosphine आ रहा है. phosphide से phosphine आ रहा है. arsenide से arsine आ रहा है. right or not? arsenide से arsine आ रहा है. that is deuterated arsine, deuterated phosphine. Normally with water means phosphine, normally with water means arsine. This is deuterated arsine, deuterated phosphine. Okay, so these are the reactions, right? Now, okay, next one. Reaction with carbides. Okay, this is calcium carbide. Is reacting with D2O, giving rise to what? CaOD taken twice plus C2D. If I say calcium carbide CaC2 plus H2O, right? CaOH taken twice calcium hydroxide and other calcium hydroxide plus C2H2. This is acetylene. Right? Calcium carbide. This is known as calcium carbide. Right? Calcium carbide. Carbides. Calcium carbide is reacting with deuterated oxide, oxygen, deuterated oxide, and you are getting deuterated calcium oxide. Okay, calcium deuterated oxide, and this is acetylene means this is deuterated acetylene. Deuterated acetylene. deuterated acetylene आपको आ रहा है calcium carbide. Okay, here reacting with water, getting what acetylene along with calcium hydroxide. Same thing here. So यहाँ पर oxygen balance नहीं हुआ ना, तो D, okay, oxygen 4 D है, इधर 2 है, इधर 2. Right? Here also you have to take 2 oxygens means calcium carbide reacting with water forming acetylene calcium hydroxide. Calcium carbide reacting with deuterium oxide and forming deuterated calcium oxide and deuterated acetylene. Right? Another one is Al4C3 aluminum carbide. Aluminum carbide is reacting with D2O. So aluminum hydroxide like this. Aluminum OD trans. कितना aluminum है? 4 है. 4 aluminum, okay, deuterated oxide. 4 aluminum deuterated oxide आ जाएगा और कार्बन कितना है? 3 CD4. 3 कार्बन है. Deuterated methane. This is methane. Okay, so that's oxygens are 12 oxygens. इसलिए 12 oxygens here. 12 oxygens here. Therefore, here is also Al4C3 plus H2O. You are getting what? Aluminum hydroxide, right? LOH taken twice. 4 here. So carbon 3 है. 3CH4. 12 oxygens means 12 oxygens. This is methane, right? Aluminum carbide here, okay, reacting with water, producing methane. Same thing, aluminum carbide is reacting with deuterium oxide, producing deuterated methane. वहाँ पर मीथेन है तो इधर deuterated methane है. वहाँ पर aluminum hydroxide है तो इधर deuterated aluminum oxide. समझ में आया क्या? त्रिनी, अर्पिता, आकाशदीप, शुभदीप, भगीरथ, असित कुमार, शुभंकर, right? Everybody got these things? समझ में आया कि नहीं? Okay, right. So these are the things. Next, last one here is 7th one, electrolysis. Right? D2O undergoing electrolysis produce deuterium plus oxygen. Right? दो deuterium है, दो oxygen means दो लेना है, balance हो जाएगा. Right? Electrolysis में deuterium oxide electrolysis करने से deuterium plus oxygen. deuterium में हो जाएगा, right? H2O on electrolysis gives what? H2 plus O2. Okay? This is 2H2O. Okay, so last property here is deuterium oxide is undergoing electrolysis, producing deuterium and oxygen. Okay, so these are the like water only. Water is also undergoing electrolysis, producing what? Hydrogen and O2. Okay, so that is right? So these are the main chemical reactions of deuterium oxide, right? So now आपको स्मॉल क्वेश्चंस मैं पूछता हूँ अभी. See one question for you. The boiling point of D2O अभी आपको दिया था. The boiling point of D2O is greater than H2O. The boiling point of D2O is greater than H2O. What is the reason? The boiling point of D2O is greater than H2O. What can be the reason? Yes. Yes, Asit Kumar, Sujata Ghosh, Bhagirath, Akashdeep. Yes. Greater extent of hydrogen bonding. Greater extent of hydrogen bonding in D2O than in H2O. Right? When SO3 reacts with D2O, the product formed is. When SO3 reacts with D2O, the product formed is. आंसर नहीं देता क्या? Deuterated sulfuric acid, very good, Mr. D2SO4, right? When heavy water reacts with calcium carbide, the product formed is. When heavy water reacts with calcium carbide, the product formed is. C2D2, deuterated acetylene, or deuteroacetylene. Okay, very good. See, one thing you must remember, freezing point and boiling point for D2O is more. Freezing point and boiling point for D2O is more, okay, than water, okay, and also density and viscosity also greater for D2O. Density and viscosity also. Are you listening? Density and viscosity also greater for D2O than water. Okay. And solvating ability किसको ज़्यादा है? मतलब solvating ability means hydrogen. That is solvating ability किसको ज़्यादा है? H2O को. H2O को solvating ability ज़्यादा है. Solvating ability means what? Undergoing dissolution. Undergoing dissolution for water is more. And dielectric constant for D2O is less than water. Dielectric constant is also less for D2O than water. In nuclear reactor, heavy water is used as. In nuclear reactors, heavy water is used as A. Option A, fuel. Option B, projectile. Option C, moderator. Option D, coolant. Option D, coolant. Option C, moderator. Option B, projectile. Option A, fuel. In nuclear reactors, the heavy water is used as option A, fuel. Option B, projectile. Option C, moderator. Option D, coolant. Yes, Akashdeep, you got the answer. Yes, correct only, Akash. What about you all? No, no. In nuclear reactors, heavy water is used as option A, fuel. Option B, projectile. Option C, moderator. Option D, coolant. So the answer is moderator. Okay, right. Moderator. What is the percentage of deuterium in heavy water? Yes, another question. The percentage of deuterium in heavy water is. The percentage of deuterium in heavy water is. The percentage of deuterium in heavy water is. Percentage of deuterium in heavy water is. कितना है? 20. Arpita, you are giving right answers always. Very good. The percentage of deuterium in heavy water is 20 here is. The most abundant and least abundant isotopes of hydrogen are the most abundant and least abundant isotopes of hydrogens. Most abundant and least abundant. Which one is most abundant? Protium is most abundant. Tritium is least abundant. Right or not? Protium is most abundant. Tritium is least abundant. Okay. So we'll meet in the evening session. Thank you very much for all of you. Thank you. Bye.